So, what is the universe really made of? I mean, what is the fundamental stuff of reality? Today, we're going to unpack that question using quantum field theory. And let me tell you, the answer is a whole lot stranger and way more interesting than you probably think. Let's get into it. Okay, let's start with a really simple question. You've heard of electrons, right? They're everywhere, powering basically everything we use. But have you ever stopped to ask, what is an electron actually made of? Like, what's inside it? And look, your brain probably jumps to a certain image, right? A tiny, solid speck of stuff, like a little marble, zipping around. It just feels right. But here's the thing. Modern physics tells us that picture is completely, totally wrong. And figuring out why it's wrong is what this is all about. So we're going to start by taking on what we can call the substance myth. This is that gut feeling, that deep-seated intuition we all have, that the universe has to be made of some kind of stuff, tiny little building blocks. But as we're about to see, that very natural idea leads physicists into a real dead end. Because here's the crazy part. When physicists finally develop the tools to look closer and closer, to zoom in on the fundamental nature of reality, something really weird happened. The stuff they were looking for, well, it started to disappear. And this really gets to the heart of the mystery. As one physicist put it, when it comes down to the actual stuff, every local object disappears. Just let that sink in for a second. The harder we look for some solid physical thing at the bottom of it all, the more it just evaporates into thin air. Which, leads to a pretty big question. If reality isn't made of substance, then what in the world is it made of? If it all just dissolves when you look too close, what is physics even describing anymore? Well, the answer is kind of mind-blowing. Physics had to basically invent a whole new language, a language that stops trying to describe what things are and instead focuses entirely on describing how they behave. And this language is pure math, built on three key ideas. First up, you've got something called the manifold. The easiest way to think about this is like the stage for a play. It's the backdrop. In this case, it's the four dimensions of space-time, three of space, one of time. But the key thing here is, it's not a container filled with stuff. It's just the abstract arena where all the math happens. Okay, so on that stage, you have what's called the state. Now, the state isn't a physical object. It's a purely mathematical concept, an abstract object that holds all the possible information about a system. You can think of it like a character sheet in a game, listing all the stats and possibilities. It's pure information. And finally, we get to the field. Now, I know what you're probably thinking. Some kind of invisible fluid filling space, like a magnetic field? Nope. In quantum field theory, a field isn't a physical substance at all. It's a mathematical operator. It's a tool, a function, that acts on one state to create another. It's the verb in the sentence, the action, not the thing itself. All right, so we've got this very abstract world with a stage, some information, and some actions. But what gives it any structure? What makes it look like our universe? The answer, in a word, is symmetry. Symmetries are the fundamental rules of the game. They are the bedrock that governs everything. And this right here is probably the biggest mental leap you have to make. In quantum field theory, a particle, like our electron, isn't some little thing that has to follow the rules. A particle is the rules. It's a direct manifestation of the underlying mathematical principles. It's what the rules look like from where we're standing. And this is where it gets really cool, because it's not just some philosophical idea. Check this out. These abstract rules directly create the physical properties we can actually measure. So for instance, there's a set of rules, a symmetry, that describes how things behave when you rotate them in space. The result of that rule, the property we call spin in an electron. Another rule, another symmetry, demands that a photon has to be massless. The rules come first, and the particles and all their properties, they're just the consequences. Okay, I know, that was a lot of abstract, mathy stuff. So let's try to ground all of this with a really simple but really powerful analogy that I think is going to make this whole new way of thinking just click. So first, let's just lay out the two different approaches side by side. You've got the old way, the substance-based thinking, which asks, what is a particle made of? What's its real shape? And then you have the new way, the relation-based thinking, which asks, what are the rules for how a particle behaves and interacts? Quantum field theory says only that second question actually has an answer. And the absolute best way to get your head around this is to think about a game of chess.
To play chess, do you need to know what a knight piece is made of? Is it wood, plastic, marble? Does it matter? No, of course not. All you need to know are the rules for how it moves, the L shape, and how it interacts with other pieces. Its substance is completely irrelevant to the game. Quantum field theory says reality is just like that. Physics is the science of the rules of the game, not what the pieces are made of.
So let's bring this all home. The really crucial point here is that quantum field theory forced physics to completely change its job description. It's no longer about searching for some ultimate fundamental substance. It all boils down to this one incredibly powerful idea. Physics doesn't tell us what nature is. It tells us how nature behaves. It's a science of actions, of relationships, of transformations, all of it governed by a deep and surprisingly elegant set of rules we call symmetries. So let's just quickly recap the big points. The world QFT describes is fundamentally abstract. States and fields are just mathematical tools. The real foundation of reality, that's symmetry, the rules of the game. And that means asking about the real shape or the substance of a particle is a question that just doesn't make sense anymore. At its heart, physics is the science of what we can measure and how all those measurements relate to each other. And that leaves us with one last kind of wild question to chew on. If physics has really just become the science of the rules of the game, well, it really makes you wonder, what exactly is the game board and who or what is playing? That's something to think about. Thanks for tuning in.